Hello and welcome to LabVIEW Advantage. Today you'll be learning about polymorphic VIs in LabVIEW. Here, to start with the polymorphic VI, what it basically means is the polymorphic VI can run a specific instance of any function based on the different data types. Here, as you can see, I have already created 4 different VIs. They can handle individually the double data type, integer data type, hex data type, and then the octal data type. So to begin with, what we'll be doing it is, first of all, you created all the functions and they all need to share the same connector pin. As you can see, the first one, as you can see, is the double. The next one is for the integer, then the octal, the hex function. So here what we're trying to do is each of the function is basically used to square the provided value. What you can consider is we actually use polymorphic VI by going into the new function. As you can see, there's an option called polymorphic VI. Then you press OK. And now it will ask you to add the different instances of different VIs. So I'm going to press add and then consecutively add all the VIs I have already created. So this is a very simple VI that does the square of the value. And I'm going to make a meaningful icon for this particular VI. I'm going to write a square followed by the symbol of X square. And press OK. Once I complete it, there's an option where I can show the different option of the particular function that is calling. So I'm going to check it on so that you can see what is required. So once I do this, I'll be saving the VI. So file save, and I'll save it as a square. And now the next thing I'm going to do is I'm going to close this dialog box and then do file new VI and then drag the polymorphic VI into our block diagram. As you can see, by default it is calling for the double data type. If you click the list down for the polymorphic option, can help you select the different data type. As you can see, I can hide that one as well. For the sake of this demo, I'm going to make 4 copies. I'm going to create the controls and indicator. As you can see, I'm going to make a control out of that one number. Although by default it was a double, the moment I connect it has changed into integer. So the polymorphic VIs will adapt according to what data type it has been selected. As you can see, the control and indicator that has been created on the first instance of this particular function is basically turned into double. And the hex and octal, both of the data types are basically the string. So I make a copy and I create the indicator on both, but as you can see, it's actually showing hex rather than the octal. The main reason is both of them has been selected as a hex. So in this instance, the third instance, what we'll do is, since we need it to be octal rather than the hex, I'm going to right click and visible items and polymorphic selector and select into octal. So now what is going to happen is, if I delete, I don't need to do anything, I just need to change the text because the data type remains the same. So after making the changes, I'll be running this VI. So basically you can use the polymorphic VIs when you don't want the same kind of function to be repetitive again and again. One VI can actually take care of many other functions in the block diagram. So you don't actually need separate versions of the same kind of code to handle different data types. So this is a very simple example. After I arrange the controls and indicators, now I'm going to run the VI. As you can see, when I make some changes, I can actually see the values being separated. In octal, like I have to ensure that I enter the values between 0 to 7, and same thing I can do in the hex as well. Hex, I have to ensure I enter the values between 0 to F. So once I've done, I'm going to take you back to our original codes that are actually being called using the polymorphic VI. So you have to, as you can see, like you have to ensure that the connector pane of each of the function has to be same. Now if you look here, as you can see, the first one is using the double, second one is integer, third one is string. One of the things what you can do with the octal and then the hex is you can have some like error handling capability, so that in case the user enters the value outside the hex or the octal value, then it can throw the error and let the user know. So I hope you like this video. Please like, share and comment on this video, and do not forget to subscribe to this channel for future LabVIEW videos. Thank you very much for watching.